put my phone on airplane mode real quick. All right, my name is Stephen Arena, and this is my portfolio. So, being born in small town USA, it's sometimes hard to find what you're passionate about. That said, growing up, I would always follow my dad around his workshop and try to help with him with whatever he was doing or making. And now that started with just holding a flashlight and then to handing him screws and drills and then finally to actually helping him with the construction. Now, this was great because it got me started in the field of making and working with my hands. Growing up, I was in several clubs and organizations ranging from 4-H to Technology Student Association to Fellowship of Christian Athletes. Now, I've always been a busy individual, as in I was in all of those clubs and organizations, and I played 5 different sports growing up. Now, because I was so busy, my parents made sure I had a car as soon as I could drive so I could take myself anywhere and everywhere I needed to. That car, my first car, was a BMW Z4, and that sparked an interest in cars and automobiles to the point where I spent one summer learning how to disassemble and reassemble engines and how to change and replace radios, and that allowed me to put a new amp and subwoofers in my car. Now, that takes us directly into the theme of my portfolio. The following theme showed itself time and time again in my work, both while at Berry College and elsewhere. Transportation technologies designed to increase the safety of the user. To dive deeper into this theme, transportation technologies are anything that assist in some fashion the user. Prior examples of such technologies are the car horn, the bright setting on headlights, and the seatbelt. I should also mention transportation technologies are not exclusively limited to passenger vehicles. Essentially anything that moves, controlled by a user, falls under this category. Excuse me. That means a tank, an airplane, or even a riding lawnmower are all enveloped in transportation technology. So finally, the user in this theme is primarily the individual that the technology is affecting directly. An example is where the bright headlights affect the driver by increasing their line of sight while driving in the dark. Keeping in touch with lights, my first piece of work I'd like to show you ties in quite nicely. So the first project I'm presenting to you is a project called Dashboardless Speedometer. This project was designed for my bicycle, but it can be easily modified to any vehicle, while of course its focus is for vehicles without dashboards. The purpose of this project was to design something that would allow the user to know how fast they are going simply by looking at the handlebars. On the handlebars is a strip of neopixel lights that intuitively light up to portray information about the speed of the bicycle and the user. Featuring an Arduino N52 magnet and a magnetic sensor, and a neopixel strip consisting of 20 lights on this device. Now, using the circumference of the tire, number of rotations, and time, this project, it used a little bit of math to calculate the speed. The math in the software includes counting the number of rotations for every 5 seconds, the distance traveled per rotation, and then using that information, the software would calculate the speed in miles per hour and portray that information through the neopixel strip accordingly. As the vehicle increases speed, one light will light up for every 2 miles per hour. And then at 15 miles an hour, the lights, which were all green, would turn yellow, and then at 30 miles an hour, they would change again, but this time from yellow to red. This was done to give additional information to the user about estimating their speed. If I were to continue with this project, I would convert the Arduino Uno into an Arduino Nano, which would allow for the box on the front of the vehicle to drastically shrink in size, as it is what housed the Arduino. Additionally, I would do more to insulate the wires I soldered, Now, whether that be with heat shrink or hot glue, I would probably lean toward heat shrink, but I would also experiment with finding a more permanent way to secure the N52 magnet on the front of the tire. Now, for my second project that I'm presenting is actually my first project as a creative technology major, and it was born of necessity. I personally do not like eating while driving, but am able to acknowledge that it is sometimes necessary, especially when running late. The purpose of this project was to free one hand so you can always have it on the wheel. While two hands on the wheel is admittedly the safest, one hand on the wheel is significantly safer than zero hands. And while dunk driving doesn't magically make you on time, it does help you get to your destination safer, assuming your food choice is a dippable finger food. As you can see in this picture, the green and black arms are approximately 2 feet long and adjustable. And then at the bottom, it has 2 cup holders, and at the top, it has a sauce holder, which was designed in Tinkercad and then printed in Hackberry Lab. So, as mentioned earlier, the sauce holder was designed in Tinkercad, but it was also designed in a way to fit every rectangular sauce container. This meant many trips to fast food restaurants, which I did not hate, to gather a surplus of sauce containers and then measuring them all so I could create dimensions that would allow them all to fit in the container. In the picture on the right, Zaxby sauces sit in the box a little bit higher than others that would fall flat with the top of the box. This is because there were lips on the corners that prevent the Zaxby sauces from sitting all the way down in it. It happened, however, that where those lips were cut was the exact same dimensions as almost every other rectangular sauce. The adjustable arm is made out of 3 2-foot-long legs of a material called GorillaPods. These were bought on Amazon and proved a remarkable material as they could be adjusted into nearly any position and were rigid enough to hold the weight of the box and the sauce. The 3 legs had 2 of them attached to the cup holders, and as you can see in the picture on the left with the 2 holes cut out in the middle, and one that was left only attached to the box. This was to allow an extra leg of support for whatever position the user wants the sauce. The cup holders were constructed on the lathe from a piece of 4x4 lumber. By creating it with a slight taper on the cup holders, they were able to fit in most cup holders and still hold drinks from fast food restaurants. The spacing for the cup holders was determined by measuring 5 vehicles' cup holders and using the one size that 4 of the vehicles shared. I had this in my truck when I went home, actually, and 3 people tried to buy it off me, which proved it just proved to show the utility and the desire for this project and this product. On to my third set of related work. It's actually focused at my current job. I currently work at RCI, or Racing Communications, Inc. As its name suggests, all the work here is designed for racing vehicles. Everything you see on the screen in front of you are specific things that I have worked on while there. Now, looking at this technology listed, they don't all seem to be directly related to each other. Granted, they of course all go in race cars or in the pit area. However, they are all designed to improve communication, which inevitably increases safety. At speeds of 200 miles an hour, communication is essential to safety. When communication fails, accidents are bound to occur. And at those speeds, accidents are often fatal. This means this means everything I do has to work reliably and consistently. For now, let's focus on antennas, which will also come into play later. At RCI, I am the sole employee who builds antennas and the coaxial counterparts that go with it. Without these antennas, communication between driver and crew would be staticky at best and non-existent at worst. As I mentioned earlier, no communication could easily prove lethal. That means that my work, though it admittedly goes unnoticed by most, is a key part in the success and survivability of the race car drivers. On the right are two of the most common antennas that I make. The left is called a star antenna, and the right is called a flex blade antenna, both of which communicate on the 460 megahertz spectrum. Focusing on the star antenna, it consists of a ground plane, a whip, two brass contacts, and a buildup around the whip. The ground plane is the cross-section that gives the antenna its name, and it helps improve the quality of the signals. The whip is the either stainless steel or nickel titanium cylinder in the middle of the antenna, which people will often call the antenna when talking about it. The brass contacts allow the whip to connect to the coaxial cable and thus transmit information. And finally, the buildup is the black cone at the base of the whip, used to both create a pressure seal and reinforce the whip. While my job description requires me to only assemble the antennas when required, I was blessed with an opportunity to develop ways to both make the antennas faster and cheaper. Using a CNC mill at work, I began machining connector pieces out of aluminum, which would hold the second brass connector, again allowing the coaxial cable to connect with the whip. So as I began machining these connector pieces out of aluminum, it let us save money because we don't have to purchase as many pieces, and we never ran out because I could always make one if I needed one. Meanwhile, with the flex blade antennas, using a series of clamps, I was able to construct a mechanism that would let me make blade antennas in a third of the time it would traditionally take. These improvements and opportunities were only able to show themselves due to my time in Hackberry and my classes with Dr. Grout for teaching me how to use the metal shop. Finally, with my capstone project, it too focused on antennas. Seeing as I'm surrounded by them at work, my boss and I wanted to try and create a better antenna that would not shear off and would not be affected by radio or physical interference. From that, the following problem statement was derived. Race car drivers often experience difficulties communicating with their team on the backside of several tracks because of both radio and physical interference. Upon more research at school, machining a new whip and creating an entirely new antenna proved out of the question, as it requires tools I did not have readily available to me at Hackberry Lab. From there, I had to pivot, and that took more research. And upon talking with my boss further, I found that nickel titanium antennas, which were also mentioned earlier, were exclusively used in VHF antennas, but not UHF antennas, because they had a tendency to shear off. This meant that stainless steel whips had to be used in the cars that communicated in the UHF ranges. From there, I decided I would find a way to prevent the nickel titanium whips from shearing when on cars that use UHF antennas. This led to the design and prototyping of buildups around the whip in an attempt to reduce pressure on the whip and eliminate the shearing. To begin this process, I took Diffusion 360 to design several buildups, where I settled on the design you see on the screen. It was easily manipulated to create different sizes, and then they were all printed on my own 3D printer. The top right picture compares these many variations of the same buildup next to the two parts of the standard buildup on the far left of that same picture. In order to help keep all the prototype buildups separate, they were all color-coded, and that was used for my testing. So following several tests in the area of flexure strength, as seen in the bottom right picture, every one of my designed buildups tested better than the standard buildup when tested with a whip alternative. When tested with the stainless steel whip, however, the whip proved stronger than any of my buildups, and tests on that front provided no fruit. So that led me to the conclusion that if I'm going to keep going, I need to focus my research on stronger materials, where I have done these tests and I have found that certain shapes and certain variations of certain variations of this model worked better, I still need to find something that is actually stronger than the stainless steel whip. So the first material that came to mind was Delrin, which has a strength of 11,000 psi, which is 3,500 psi stronger than PLA, which is what my prototypes were made of. And it also already has a presence in the communication world, as it does not impact the quality of reception on antennas. So looking towards the future, I currently have an offer that is a promotion at the current company I work at. This promotion will put me in charge of designing all the circuit boards, and I'm, excuse me, and I would be taking over all the Fusion 360 design work for the company, and I would be in charge of all 3D printing and maintaining our printers. That said, I am always looking on Indeed to find jobs that will pay a little bit more or have more opportunity for lateral movement inside the company. And I am primarily focusing on jobs related to mechanical engineering or electrical engineering. And I'm done. And I went over, I'm sorry.
Okay, not too bad. So, all right, thank you very much, Stephen. So appreciate it. And we'll go ahead and open it up to